Good morning. If you're looking at this paper, you see that we have this paper right in front of us that says determining tables. What we're going to do is we're going to begin going back and thinking about how we can use rules and how determining a rule in a table is related to our coordinate graph information. So the first thing I want to do is go back to the very beginning of school and even back to 4th grade when we were talking about a rule and how we apply a rule. So that's where we're going to start today. So today, number 1 says circle all the tables below that represent y equals 3x. And so when it says circle all the tables, that kind of gives me a hint that there's probably not just one answer. So when I look at this information and I see y equals 3x, I want to think about whenever I have an x value, I'm going to be multiplying that by the number 3 to get the y value. In fact, I'm going to go ahead and write that rule all the way across so that I remember that it's my x value times 3 to get my y value. And that rule is the one that we're looking for. So as I start off, I notice that I've got some decimals. And I'm noticing right away that if I plug in the number 3 here, 2 times 3 is going to give me the value 6. So I know right away that this table is not going to follow the rule that they've given me. So I'm going to go ahead and X that out. And just glancing across, I see some really easy ones without a decimal. So I'm going to go ahead and use my energy on those first to kind of eliminate some that I know are not right. So if I plug in the number 3 here, because 2 is my x value, is 2 times 3 going to give me 6? And it is. Is 3 times 3 going to give me 9? And it is. Is 5 times 3 going to give me 15? It does. And does 6 times 3 give me 18? It does. So I can go ahead and take my highlighter and I'm going to go ahead and circle this as one of my answers. Yes, I have skipped this one, but I noticed again that there are decimals here, so that's going to take a little more thinking. And I'm going to go to this one next because we have whole numbers still. So if I plug in the number 3 times 3, will I get the value 1? And no, I won't. And in fact, if I plug in the number 3 all the way down, I will not get that value y. In fact, if I'm thinking about how these are related, it is not by multiplication, but it is in fact by division. So we would be dividing by the number 3, not multiplying by the number 3. And since we're dividing by the number 3, that does not follow the rule. So I'm going to go ahead and I'm going to X out this one. That brings me back to the second table. Because I skipped it earlier and I noticed that we had decimals, I know that this is going to require a little more thinking. So what I'm going to do is I'm going to give myself a little bit of space, which is why I skipped it first, so that I could come back and I could solve each one of these. So when I plug in the number 2.5, which is the x value, and I multiply it by 3, I have to think about what will I get. And so if I multiply 3 times 5, I'm going to get 15, and I'm going to carry my 1. And if I multiply 3 times 2, I'm going to get 6 plus 1 would give me 7. And then I've got to bump my decimal over 1 place value to the tenths. Is that what is being shown here? It is. So I'm going to go ahead and give it a check. I'm going to go in and plug the second number in. That's 4.5. We're going to multiply it by a value of 3 to see if we can get this answer. 3 times 5 is 15. 3 times 4 is 12, plus 1 more gives me 13. And I'm going to bump my decimal over one place value because I have one number behind the digit. 13.5, is that what's represented in my table? It is. I'm going to give it a check. I always want to make sure that even though I get some that are correct, I always want to go ahead and complete the entire table because sometimes they will throw one in down here that does not belong with the set of data. So I'm going to rewrite the number 5.5. I'm going to multiply it by 3. And when I multiply 3 times 5, I get 15. Carry my 1. And 3 times 5 is 15, plus 1 more gives me 16. Bump my decimal over, and I get 16.5. That does indeed follow the rule. And I have one more. 6.5 times 3. So 3 times 5 is going to give me 15, carry my 1. And 3 times 6 is going to give me 18, plus 1 more makes 19. I have to bump my place value, my decimal over one place value, and I do in fact get 19.5. So there's my second table. I'm going to go ahead and take my highlighter and circle this. So remembering some vocabulary. Are these tables examples of additive relationships or multiplicative relationships? That's right. These are examples of multiplicative relationships. Multiplicative relationships are always going to use either multiply or to divide to be able to show us the relationship between a set of data. That could be your X data and your Y data, or it could be any other kinds of data that you're looking at. But if you multiply or divide to get that the relationship, then you are using multiplicative relationships.